Okay, in the last video we left off on this Autodesk Inventor part, and right now I'm just going to show you how to export this into Cinema 4D and a little bit more about Cinema 4D, like the parts of it and everything like that. To export it, you go to File, Export, and then CAD format. And I found that Cinema 4D best accepts .obj files, so I'll just do hexagons .obj, and then it's important to go into options. Sometimes this resolution will be some of these other values, but which can lead to actually low quality. So sometimes you for like small things you can use high, but for if you have like thousands of parts, high resolution can sometimes even be too many polygons. So I mean, I'll just do medium for this one. High will probably work, but just to be safe, and it doesn't affect quality that much at all. It's only on if you look at the rounded parts and you zoom in a lot, that's where the quality starts to show. Okay. And it might take Autodesk Inventor a little bit to export it, but it should finish if you just wait. Okay. So now we can go into Cinema 4D. And as like a little disclaimer, I'm going to be using Redshift render. So it doesn't come with Cinema 4D. It might in the new version, but not in Cinema 4D R19. But it's the Redshift render plugin, and the requirement is that you have an NVIDIA graphics card, and if it's recent and has like 2 or to lowest like 4 gigabytes VRAM, then you should be fine. So like 700 series, maybe lower. I have never tried that, but you need a NVIDIA graphics card for this to work, and you can use multiple if you want. So to open it, you can go to File, Merge, and find the OBJ that you just saved. And Autodesk Inventor generated this .mtl file, which is materials. It can be a little helpful, but we're going to be replacing the materials anyway, so we won't bother with that. So you go to hexagons, or the OBJ file, open it, and we don't have to import material file. So you can do different presets, but scale doesn't really matter here. And splitting, this is, if I import this file, it's going to split up all the objects. It's going to show them on a tree list. You'll see that later. But this changes how that list of parts is organized. I'm just going to leave it like this. Leave all the axes stuff. And the only thing I changed was no material, but that doesn't really matter either. You can delete it later. And then you'll see down here it's loading objects, vertices, and it should finish soon. Okay, so looking over here, this area is basically your tree of all your parts. So you can plus minus and scroll. So we actually have almost 500 of these, and so to navigate in Cinema 4D is a little different than Autodesk Inventor. If you click and hold 1 on the keyboard and then right click and drag, you pan. If you click and hold 2, on the keyboard, right click and drag, it's zoom, and then if you click and hold 3, it's rotate. But once you get used to this, it should be pretty easy to navigate. And then we'll also be using like cameras, and you can do different things with that. So to create a redshift material, we want to put on a material for this basically. So you can see that it actually looks like aluminum or whatever you want on this. So we want to put on a material on this to make it look a lot nicer and then render it. To do that, you can go to Create, Redshift Material, double click to edit, and then the easiest way is to go to RS Material and then go to these presets and just do aluminum. But you can, there's like a shaded graph here, and you can easily do a lot of complex things like materials and actually put in like textures and things like that. But we'll just be sticking to this one and maybe fine-tuning this a little bit, but we're not going to do much with that today. So the material is right here, so I can just call it a L whatever. And to put it on the parts, you can just select all the parts. So here are the like a toolbar. So move is if I click on parts, I just move them, or we could just do live selection. So I can just click and hold and just select all of them like this. There's also like rectangular selection where you can oh, I didn't hold shift, so it deselected the other ones. But there's also like rectangular selection. If you click and hold on this, and then you can just select all of them like that. And now that they're all selected, you can just drag this material onto any one, and it should be right there. So the next thing that we need, we have materials, we need lights. So this seems pretty evenly lit. There's a couple different options. There's a default one, and then there's some more advanced lights. We'll probably use those because they might look better in this case. So go to Redshift Lights and then Area Light. So you see it's generated this light, and you can use these little arrows to move the axes, and then use these to move 2 axes at once. So this menu down here, basically for everything, is like a parameters menu. So here, if we go to coordinates, basically everything has this. Like if we go to hexagons, it has that too. Everything has this menu. We can go to these degrees and change these angles. So I'm basically going on the arrows and dragging up, clicking and dragging up and down, or you can just type them in manually. So drag them like this and try to make we'll like fine tune this later, but and then you can change and click and hold on these to make it bigger. That's also in these menus. And another thing is, in general, intensity. You can make the intensity up or down, but we'll try 1 for now. So finally, we basically need our camera. So if we go to Redshift, Camera, Standard, you can see this little video camera here. So to go into this camera, there's a button over here, and now we basically are the camera. So we can still move, and if we exit the camera, it's right there. So this is basically just us going into the camera. And the reason for using a camera is just to have more settings. Like see this blur in the background? That's we can do that using the camera. I'm gonna save this file just to not lose anything. So we can zoom in and kind of find the the right angle, but as you can see, there's like a sideways angle here. So we can go to camera coordinates and then mess with these angles again and see how it's kind of shifting the whole thing. We can recreate that to go like this. And then another setting you might want to change is actually let's just leave it like this for now, and I'll show you. There's this Redshift render view. This is like a preview for what the render would look like. So you can just click play. Okay. So this is depending on like your graphics card and stuff, it'll be faster or slower, but this is kind of what the final rendered product will look like. As you can see, we're starting to get those lights and reflections that you have in here. So the first thing I notice is these are way more reflective. So we can double click on a material, go to RS material, and go to the reflection and change the weight a little bit. So you'll see, like, if we put it down to 0, there's no reflection, so no light. But as soon as there's something, it starts becoming a little more reflective. So I'm just gonna put it like right around here, just guessing. And I'm gonna go into the area light and boost the intensity a little bit. And that's looking pretty good. So we need to sometimes it gets so bright that you can't even see it. So if you go look at these little dots here where my mouse is, this is visibility. So this is visibility in renderer, or in preview, and this is in rendering. So if we have this, we see the light now but not in rendering. But if you click on the dots, now we see it in here, but we don't see it in rendering. So our view isn't really obstructed by the light. We could keep fine-tuning this until it's like, and this is not the final render, it's just like a little preview. So it's usually good to kind of hold this window open and kind of mess around with the view until you find something that looks pretty good. Yeah. So I'm just gonna mess around here, just try to find a good angle that we can show. And another thing here, if we go into our camera, I think Redshift camera, in one of these here, we can change things like focal length. So see how that just that's like ultra wide, normal. This might be more of what we want to go for, comparing it to the picture, but that's also just preference. And we could have some black in the background. I think it looks pretty good, but at this point it's just complete preference in all cases, basically. So yeah, I think that looks pretty good, and I'll show you how to do the final render and what the render settings mean. Actually, we need the bokeh effect, which is the blur. See how these ones in the back are blurred? We can replicate that by going to our camera, Redshift camera, bokeh, and then enable it. So right off the bat it's extreme, but it's just, instead of deriving focus from camera, we can manually change it. So I'm just guessing, but you can see that right now the back ones are in focus if we want that, or we can do like 90. The front ones are in focus. So let's have this, and then change the, you can see what everything does. So like this radius, if we make it tiny, it does that. I'm just going to put it back to 1. And then the power is how it just changes the how much bokeh blur there is. And then aspect is kind of like smearing, but you can just experiment with these and see what each one does. So we don't need that much power. Actually, I'm gonna try maybe 0.5. This aspect like 1. This maybe 0.5. And now only the ones in the back are blurry. We might even want to make that even less. So like 0.3. So it's just a subtle blur. Yeah, I think that looks good. So let's go into, if you accidentally get into these menus, it's F1, F2, F3, F4, F5. Just go through different views. So F1 always goes back to this one. Go to edit render settings and make sure you select Redshift. So output menu, you like change the resolution, just 1920 by 1080. Doesn't really matter. Just you can do almost anything. We don't need any frame rate or anything. It's only one image. Save is where you save it. So let's do it here. Okay. And I use TIFF because I think it's lossless and should be better than PNG, but you think you can barely tell the difference. I just use it. And then finally, Redshift is where all the big rendering settings are. So these samples are the main thing you're going to be changing. So minimum sets the minimum samples for the whole scene, and maximum sets maximum. So let's say, samples, you can think of this as quality, basically. So you don't really have to worry much about the max. It only really comes into play if you change the sample, because you can change sample rate for let's say this light. We can let's say make this sample like 500. This max will limit what this is. So with scene optimization, you can, to render faster, you can make like the light samples higher, and then you can make all the samples lower or something. But for pretty quick results and that are easy, you can just use lower settings. So for like final renders, I like to go around like 400 or 500. So I guess I'll just do that. But that's really high. You can easily on lower, it'll still look pretty good. You can just experiment this. For global illumination, this kind of helps. You can test this on and off, but it's like a pre-pass render that helps denoise low light. So I use these settings. It's just irradiance, cache, and the point cloud. For system, the bucket rendering is just once we're rendering, you're going to see these orange squares and it just shows how big those squares are, and this only really matters if you have more than one graphics card. Automatic memory management helps speed it up, and I think those are all the settings. And I'm also going to check my this is just for me checking the graphics settings I have, because the version of Redshift I use doesn't support 2000 series graphics cards. The newer ones does, but yeah, I'm just using, okay. So to render, you just click render to picture viewer, and this will just save it to the file that you specified and render. So I'm just going to click that, and right now it's doing the point cloud, you can see, and now it's actually rendering. So you see these little squares, that's the bucket rendering settings. So yeah, depending on how many graphics cards you have and your settings and everything like that, your rendering will go faster, but it heavily relies on the graphics card. The CPU isn't super important. And I think that's, it's not exactly the same, but we're not going for exactly the same. We can just do anything that looks pretty cool. So I think that's it. In some of the next videos, I'll show how you can get these like realistic textures on here, but for now you can just test out different materials. So let's say I want to make this gold, and then just render it again, and just like that they're all gold. So I think that's it for this tutorial. If you have any questions, like leave a comment or something, I'll try to answer. I think that's it.